A 5 kilogram mass placed at the origin and a 9 kilogram mass is placed at x equals 2 meters. Where is the center of mass? So let's draw a picture. So here's the 5 kilogram mass. And this is going to be the 9 kilogram mass. So this is at position 0 with respect to the origin. And this is at x equals 2. So where do you think the center of mass is going to be located? Now it has to be somewhere between the 5 and the 9 kilogram mass. Is it going to be closer to the 5 kilogram mass or the 9 kilogram mass? What would you say? The center of mass is going to be closer to the more massive object, so it should be somewhere between 1 and 2. To calculate it, you can use this equation. It's the mass times the position of each particle. It's the sum of those values divided by the total mass. So in this example, M1 is 5, and the position of M1 is 0. The second mass is 9, and its position on the x-axis is 2. And then we need to divide it by the total mass. So 5 times 0 is 0, 9 times 2 is 18, and 5 plus 9 is 14. So it's going to be 18 divided by 14, which turns out to be about 1.29 on the x-axis. So that's the position of the center of mass. And as you can see, it's closer to the 9 kilogram mass as opposed to the 5 kilogram mass. It's between 1 and 2. An 8 kilogram mass is placed at y equals 3. Where should a 10 kilogram mass be placed along the y-axis so that the center of mass will be located at y equals 4.5? Well, let's draw a picture. So this is the x-axis, and this is the y-axis. So at position 3, we have the 8 kilogram mass. And at 4.5 is where we want the center of mass to be. So therefore, we have to place the 10 kilogram mass above the center of mass so that the center of mass will be located at 4.5. The question is exactly where on the y-axis do we need to place it? So we could use this formula. The center of mass along the y-axis is going to be m1 y1 plus m2 y2 divided by the total mass m1 plus m2. So we have this value already. It's 4.5. Mass 1 is 8 and it's located at position 3. Mass 2 is 10 and we're looking for its location. And the total mass is going to be 8 plus 10 or 18. So we have 4.5 is equal to 8 times 3, which is 24. And 8 plus 10 is 18. Now let's cross multiply. So we have 4.5 times 18, which is 81. And that's going to be equal to 24 plus 10y2. So now let's subtract both sides by 24. 81 minus 24 is 57. So 57 is equal to 10y2. And then let's divide both sides by 10. So the position of the second mass should be at 5.7 meters if we want the center of mass to be at 4.5. Number 3. The positions of masses 4 kilogram, 6, 7, and 10 kilograms are 0, 0, 4, 0, 0, 5, and 5, 6. Determine the position of the center of mass of this system. So first, let's draw a picture. So the first mass, the 4 kilogram mass, that's located at the origin. Then we have another mass, the 6 kilogram mass, which is located at position 4. So this is 4 meters here. And then there's another one at 0, 5, So that's the 7 kilogram mass. And then we have another one that's located at 5,6, which should be somewhere in this region. So that's the 10 kilogram mass. So with this information, how can we determine the position of the center of mass of this entire system? So chances are, if we had to estimate, it should be somewhere in this region, because the majority of the mass is close to the 10 kilogram mass. So it should be somewhere in the middle of these four masses. So how do we go about calculating the center of mass? For one thing, we need to take it one step at a time. Let's calculate the x-coordinate of the center of mass. So because there are four masses, it's going to be m1 x1 plus m2 x2, and then m3 x3 plus m4 x4, divided by the total mass. So the first mass, the 4 kilogram mass, is at a position of 0 along the x-axis. So this is going to be 4 times 0. The second mass is located at x equals 4. So that's going to be 6 times 4. And the third mass, the 7 kilogram mass, that's at an x value of 0. And then the last one, the 10 kilogram mass, it has an x value of 5. And then let's divide it by the total mass. So that's 4 plus 6 plus 7 plus 10. So these two, they're going to disappear. They don't have any value. 6 times 4 is 24, and 10 times 5 is 50. Now 4 plus 6 is 10, plus another 10, that's 20, plus 7, so that's 27. And 24 plus 50 is 74. So 74 divided by 27 is 2.74. So that's the x-coordinate of the center of mass. Now let's do the same for the y-coordinate. So it's going to be m1 y1 plus m2 y2, and then you get the picture. Now let's divide it by the total mass. So mass 1, which is 4 kilograms, is located at y equals 0. The second mass, m2, is 6 kilograms, and the y value is at 0 as well. The third one, the 7 kilogram mass, is located at y equals 5, and the last one is located at y equals 6. And then divided by the same total mass. So we're going to have 7 times 5, which is 35, and then 10 times 6 is 60. And we know this is 27. 35 plus 60, that's 95. So 95 divided by 27 is about 3.519. So that's the y-coordinate of the center of mass. So that's it for this problem. A 10-meter long 4,000 kilogram truck has its center of mass 4 meters behind the front of the truck. Where should a 1,400 kilogram load be placed so that the center of mass will be right in the middle of the truck? So let's draw a truck. Okay, my drawing's not perfect, but you get the picture. So we're going to say this is the front, so that's going to be position 0, and this is 10 meters because the truck is 10 meters long. Now the center of mass of the truck is 4 meters behind the truck, so that's going to be at position 4. We want to place a load somewhere in the back of the truck so that we can move the center of mass from position 4 to position 5. That's the goal of the problem. So where should we place the 1400 kilogram load to move the center of mass from 4 to 5? So keep this in mind. The blue dot represents the center of mass of the truck alone. The green dot is the center of mass of the truck and the load combined. So in order to determine where we should place the load, we need to use this equation. The center of mass of the truck and the load is equal to the mass of the truck times the center of mass of the truck plus the mass of the load times the position of where the load is located divided by the total mass. So the center of mass of the system is 5. That's where we want it to be. The mass of the truck is 4,000 kilograms, and the center of mass of the truck is at position 4. The mass of the load is 1,400, and we got to find out where to place it so that the center of mass changes from 4 to 5. And the total mass is going to be 4,000 plus 1,400. So that's 5,400. Now let's cross multiply. So 5 times 5,400 is 27,000. So that's equal to 4,000 times 4, which is 16,000, plus 1,400 x 2. So now let's subtract both sides by this number. So 27,000 minus 16,000 is 11,000. And so that's equal to 1,400 times x 2. So now let's divide both sides by 1,400. 11,000 divided by 1,400 is equal to 7.86 meters. So that's where we need to place the 1,400 kilogram load in order to move the center of mass from 4 to 5. So it should be somewhere around this region. It's still relatively close to the back of the truck, but it's not all the way at the back.